Today is the 8th of March 2024, and this will be our second trigonometry lesson. Okay, we started with the intro the last lesson, and I shared with you most of the equations, SOHCAHTOA, the sine rule, the cosine rule, Pythagoras theorem. Okay, all these are under trigonometry. And then we look at one example. That is all what time could allow. Okay, now before I begin today, looking at what we want to do today, thank you very much, everyone who have subscribed. Okay, thank you so much. And if you haven't already and you like our videos, please subscribe, share, like, follow, nice comments, and if the account is not yours, ask permission from the account holder. Okay, or or take your phone to wherever you're watching the video from, ask them to help you open your account, subscribe. When we upload, then you get your own notification. Please follow my notes/scripts. It's always in the comment section. Okay, this is math. So for instance, this is 3/11, a fraction. That is 0.2727. Okay, so if you hear like 0.727, go by the notes. Okay, beware of scammers. Okay, please take care of yourself online. If they start asking you for donations, it's not coming from me. Okay, if I have something to say to you, I'll say it as I'm saying to you now up front. Okay, I'm not using this platform to solicit or ask for money for any charity. Okay, thank you very much. Please watch last video for recap. Okay, it will help you a lot. Go back and watch it if you haven't watched it already. I'll start out today. Okay, before we started trig, we've been looking at terminating and recurring decimals. Okay, which we looked at a bit in the fractions and decimals, which we look at in the beginning, but now I took it up notch a bit. Okay, so the example I have here for you is change 3/7 apparently into a decimal. Okay, so 3 go outside the half partial box, and then you have 3. Because 11 goes outside, you have 3 inside. That is the denominator outside, 3 in the partial box. Okay, because 11 cannot go into 3, you put the decimal, add 0. How many 11s do you have in 32? Okay, so the 2 is there. 30 minus 22 is 8. Add 0 because 11 cannot go into 8. How many 11s do we have in 87? So the 7 is there. 7 times 11 is 77. When you subtract, you have 3. Okay. Add another 0. You have 2, 22, or 2 of 11s. 2 times 11 is 22. Subtract. You get 8, 0. So now you can see the pattern. You are going to get 0.272727. If you continue doing it, you get 0.272727. Why? Because the denominator has a prime factor of 11 other than 2 or 5. Okay, so if you want to change 3 over 11 into a decimal, first of all, you know that it will be recurring before you even start. Okay, so if you don't get that, then you did something wrong. So now 3 over 11 equals 0.272727. Now, to write it, you can write that 0.27 and put 2 dots on top, okay, and shorten it that way. But the 2 dots means 2 and 7 recur. Okay, so you go 27, 27, 27. Another example for the starter. Show that or prove that 113 over 330 equals 0.3424242. It can be the other way around. Show that 0.34242242, okay, is 113 over 330. So we did an example like this last time. So because it's a recurring decimal, we are going to say let R equal 0.3424242. Now, if you look at the recurring decimal, you have 34242424. It's a 2-4 part that recur. So first of all, you want to multiply by multiples of 10 such that you get 34.242424. Okay, and then you can also multiply again, because if you get 34 and you subtract from this, because of the 34, you can't get rid of the decimal part. So you need to multiply again such that you get 3424 points. Okay, then because you have a number 0.2424, now you can subtract. Okay, so I did 4 examples to show you. Okay, look, if you multiply by 10, this decimal is going to get shifted to one place to the right. Okay, so 10R will be 3.4, okay, 242424. Okay, now let's go again. If you multiply by 100, you have 34.242424. 24. That is the recurring part I want to get rid of. Now, that 100 is 2 zeros. Then we multiply by 1,000, 3 zeros. So now, 1000R will be equal to 342, because we have to move the decimal 3 places. 424. But if we subtract this one from that one, it won't give us what we want. Okay, so we have to go back again. Okay, because if we subtract, look at it, we have 342, 242424, but after the decimal, but here we have 424242. Okay, so this will not be right. Okay, I left it here to show you. Okay, so I'll multiply again by 10,000. Here I have 5 zeros, so I'll move 1, 2, 3, 4, 5. Okay, so now equation, so I have 0.242424 here, 0.242424 here. So if I subtract, I'm not going to add, I need to subtract to get rid of the 0.242424 part. So if I subtract equation 4 from equation 2, okay, not equation 3 from equation 1, that's why you can see that. Okay, so if I subtract equation 4, okay, let me zoom in a bit, from equation 2, this one, okay, I'm going to get 1,000. No, this is not the right one, which I've already shown you. So I'm going to get 10,000R minus 100R, which will give me 9,900R. Then this bit here, 3424 points, that all these recurring decimals. So this part will take care of this part. So I have 3424 minus 34, which will give me 3390. This you can do on top of your head. Okay, if you take 24 out of 3,400, you are left with 10, so you get 3390. Okay, I've shown you how to easily subtract and add numbers in a non-calculator equation. I think I used a starter in a couple of videos back. Okay, so now I have R equals 9,900R equals 3390. So R now will be 3390 divided by 9900. The zeros can cancel out. So I have 339 divided by 990. If I divide the numerator by 3, I have 113. If I divide the denominator by 3, I have 330. So I have proved that this recurring decimal, okay, so if I want to shorten it, I'll do 0.3424, and then my 2 dots will be at the top of the 24. to show that the 2 4 recur. Okay, so now I've proved that 113 over 330 equals 0.3434, 0.34242424. Now, the trick to answering these questions is to look at the first part and work towards the part. So, for instance, you are in Manchester and you are driving towards the south. You don't start going to the north. Okay, so you look at the recurring part. That is what you want to get rid of. So you multiply first by, you say let R be there. Then you multiply by 10. And then multiply by multiples of 10. So it can be 100 or 1,000 or 10,000. As long as you can get to this stage, that stage here, to get rid of the recurring parts, okay, then you can make out the subject, reduce it to the lowest term, and then find proof and do whatever you want to do. Okay, so questions like this, look at the end result you want, start from one part and finish in the other part. So you either start from the decimal and end with the fraction. Okay, if you have to start from the fraction, it will recur. But if it's a non-calculator paper, then you might have to use the division box, okay, to help you do that. So that is our starter today. Okay, I'll bring more of these so that we can just now that you understand recurring and what to look out for in the denominators, the prime factors to look out for, you understand when it recurs and when it terminates, okay, and which prime factors cause that. I can now bring more of this in the starter. Okay, now today we want to just look at some simple right angle triangles. Okay, then our next video I'll bring in more questions that we'll have a look at. So here, this is a right angle triangle. All these are not to scale, and I used the calculator here. Okay, I didn't use mental maths, so I used the calculator because of the tangents and the cosine and the sine inverse involved, because I don't have a 4-figure table as we used to have. Okay, so now the triangle here is a right angle triangle. That is my adjacent, which I'm supposed to find. I have the opposite, which is 12 centimeters. I have an angle. So straight away, because I don't know the hypotenuse, the long side here, opposite the right angle, I'm going to use tan. Okay, so tan of 40. So here we are going to use 12. Tan of 40 is opposite, which is 12, divided by the adjacent, which is our A. So tan of 40 will be 12 divided by the opposite divided by x. Okay, So to find x, we just move the x to this side, the left hand side, and bring the tan 40 to divide. Okay, so 2 opposite adjacent. So x equals 12 divided by tan 40. So 12 divided by tan 40 is 0.8390 on the calculator. So 12 divided by 0.8390 will give us 14.3 centimeters. Okay. The unit is in centimeters. So remember, this is not to scale. Okay. So my answer is also in centimeters. Okay. Another example. I know the angle. I have the adjacent. I know the hypotenuse. So I'm going to use car. So the cosine of 37 will be the adjacent x divided by 9. So cos of 37 will be equal to x over 9. In the end, I'll bring the unit, which is in centimeters. So x equals 9 cos 37. So 9 times cos 37 on the calculator will give me 7.2 centimeters. Again, 1 decimal place. Okay. In trig, I would advise you to leave your answer to 1 decimal place. Okay. Now let's look at another example. Okay. Now another right angle triangle. You remember when we're doing a Pythagoras? It is the hypotenuse all squared. And then this side all squared and plus that side all squared. But here we know 2 sides and we have an angle. Okay, so and we know and we are asked to find an angle. In Pythagoras, they ask us to find length. Okay, so that is one difference. I spoke to you about that yesterday. So now we know the opposites and we know the hypotenuse. So we have to use sine. So because sine of x will be the opposite 15 divided by 25. Now 15 divided by is 25, please, not 35. 25. 5 goes into 15. 3. 5 goes into 25. 5. Okay, so sine x will be 3 over 5. 3 over 5 is 0.6. So x will be the sine inverse of 0.6. Okay, so this is why you need to press the second function on your calculator. So now x, when you do it on the calculator, sine inverse of 0.6 will give you 36.9 degrees this is to one decimal place. Okay? Leave your answer in angles in one decimal place. Okay. Now another example here again. Okay, we have this angle 40. Okay, it looks similar to the first one, but I'll just move it around. Okay, and then we have the opposite, and we have the adjacent. We want to find the opposite length. Okay, so tan of 40 will be opposite x divided by 12. Okay, so x is 12 tan of 40. Again, on the calculator, 12 times tan 40, so do tan 40 multiply by 12, or if you know how to use your calculator, it's tan 40, 12 tan 40, you just key it in, and then it will give you your answer again to one decimal place, unless it asks you otherwise, like leave it to the nearest whole number, two significant figures, etc. Just keep it simple, one decimal place. So 10.1 centimeters, because our unit is in centimeters here. Okay, so x, again not to scale, will be 10.1 centimeters. Okay, now as I've said earlier, all the diagrams I use today is not to scale, and I use the calculator. Okay, so this is one of the videos where you can practice using your calculator. I hope you are using your calculator if you are in year 11 or you are writing an exam. Okay. Subscribe, share, like, follow, nice comments. Ask somebody to help you if you do not know how to have an account. Beware of scammers. Okay, if they come and ask you money or donation, say no. Just say it up front. Okay, don't even engage. Say, I'm sorry, no. Thank you so much for watching today's video with me, and I'll see you in the next.